Okay, so what's going to happen here is, it's recording, yes, turn that off. Let's go back there. Okay, so I'm just going to do question 4 because it's quite a long one and I'm not sure how much space I'm going to need. So it's question 4. And question 4 says, I copied it down here, but I'm checking I've got it right. Calculate the symmetric Fourier series of the periodic function f of t is e to the minus a mod t, where mod t is less than pi and a is greater than 0 with a period 2 pi. That is correct. Okay. So, first of all, we have Cn is 1 over 2 pi, integral from minus pi to pi, e to the minus a mod t, e to the minus j nt dt. So this was like in question 3. The Cn is 1 over 2 pi, there's the function, and it's multiplied by e to the minus j nt, and it's the integral, and it's dt. Okay, so I'm keeping one eye on the solution and one eye here, which is, right, so first of all, multiplied together e to one power, e to another power, we add these powers together. So this is, this next step, 1 over 2 pi integral minus pi to pi, e to the minus a mod t, and then we add minus j nt, so that looks like that. dt, okay, and what we do next, okay, so minus mod t, we've got to think about what happens with minus mod t. If t is negative, mod t is positive, but then minus mod t is actually the same as t. I'll just write that here, I'll write it by the side actually. So if t is less than 0, minus mod t is actually the same as t, because the mod takes away the minus, but then we put it back on again, so it's the original t. And then secondly, if t is greater than 0, minus mod t is actually, well, mod t is the same as t, because t is positive, so it's with a minus sign. So this is minus t. So this integral can be split up to where it's into bit 2 where it's negative, where t is negative and where it's positive. And that's what we do next. So it's 1 over 2 pi, so to go from minus pi to 0, e to the, now here, see look, t is negative here, so this minus mod t is t. So in that bit we just write a t minus j nt dt. And then we look at the positive bit as well. So it goes from 0 to pi. And it's e, and then minus a mod t is actually minus at minus j nt dt. Okay. So 1 over 2 pi integral minus pi to 0. This is e a minus j n times t dt plus 1 over 2 pi integral 0 to pi e to the minus a plus j n times t dt. So I've just factorised this top, taking out the common factor t there, and it's a minus j n. And here I've taken out the minus in front, so that leaves plus a there, plus jn there, because I've put the other t outside there. And if you remember the next thing to this side bit, integral of e to the kt dt is 1 over k e to the kt. So that comes up from level 3 and level 4 maths. So what we've got here is this is 1 over 2 pi. This is e to the a minus j n t. So I've got to divide this by a minus j n, because the k from over here is a minus j n. So the k there, a minus j n. and that's from minus pi to 0. The next bit, 1 over 2 pi times, and it's e to the minus a plus jn t divided by a plus and minus a plus jn, like so, from pi at the top to 0 at the bottom. Okay, so now we've got the integrals. So that one I've used, then that step there, and that has been used on that step there. Okay, that's in there, that's in there. Right, so now I've got to substitute. This is t's down here. T is 0. T is minus pi here. There's a t is pi. This is t is 0. And that's because we're integrating with respect to t here. So these values are t's. So 1 over 2 pi. We've got to put t as 0 in there. This is e. Now here we're going to have a minus jn times 0. So that's overall 0 over a minus jn. And then we've got minus e to the a minus jn times minus pi. Because we've got to put t is minus pi there, look. And then that's all divided by a minus jn. And then the next one, could have done all that, this one in one big brackets, but I'll keep it separated for now, combine them in a minute. Okay, so we've got next one, we've got t is pi. There, look, t is pi at the top there. So it's e to the minus a plus jn times pi divided by minus a plus jn. And then the next one is an e to the 0. It's a 0 there. So the 0 there is going to make all this 0. So it's going to be e to the 0 up there. So it's minus e to the 0 divided by minus a plus jn. Okay. Right, so move over a little bit. 1 over 2 pi times, this is going to be 1 over a, 1 over a minus jn. This is minus e to the minus a minus jn pi. Just traditional to put that minus right at the front, over a minus jn. And then this is going to be, right, the minus that's down here I'm going to put up there. Okay, because I think it will be nicer up there. So it's minus e to the minus a plus jn pi, all divided by a plus jn. That there, that's an a. And then this next one, got a minus there, which will cancel with that minus there to make a plus. So it's going to be plus 1 over a plus jn, like so. Okay, so let's simplify this. Right, common denominator, because we've got 4 fractions to add together. Common denominator is going to be a minus jn and times a plus jn. So let's do that down the side here. A minus jn, a plus jn, a squared, jan minus jan. This is minus j squared, n squared, which is actually plus n squared. So they cancel. So our common denominator is a squared plus n squared. Common denominator, a squared plus n squared. Okay, so this here, this has been multiplied by a plus jn. So we need an a plus jn there. And the next one, it's minus a plus jn, because this one, this has been multiplied by a plus jn to get this. So we've got to multiply the top by the same. So that's e to the minus a minus jn pi. Next one, this here has been multiplied by a minus jn, look there. So that's going to be minus a minus jn times e to the minus a plus jn pi. And then this last one here, that's going to be plus 1 times a minus jn plus a minus jn there. And they're all multiplied by this one plus 2 pi. So I can actually write that there just to save space a little bit. Okay, so if we look here, let's find a different colour now, this bit. So that jn cancels that minus jn. That's probably all I can do at this stage, but anyway, it's still better to do it than not. So for the a's, we've got 2a, so we've got a there plus 2a. And then we've got these complicated looking bits in the middle here. Okay, so this here, look, there's a minus a pi there and a e to the minus a, look, e to the minus a pi there, e to the minus a pi there as well. So, and there's a factor of a minus and a minus there. So it's 2a, I'm going to put minus e to the minus a pi here. And then inside a big bracket, we're left with a plus jn, this bit here. So we've taken the minus outside the bracket, that goes inside the bracket. We've got e to the minus a pi outside the bracket. So we've got left there, this is times e to the plus, because we've got, look here, minus minus, so it's plus jn pi. Just going to have a quick check at the solutions. I'm sort of doing it slightly different, so I'll just come back to that in a minute. And then for this next one, the minus has come outside the bracket, and the e to the minus a pi is outside the bracket. So everything else needs putting inside the bracket. So it's actually a plus, because the minus has gone outside. It's a minus jn. E, minus a pi is out, so it's minus jn pi inside. Oh, it's getting neater and neater every step. And that is all divided by 2 pi a squared plus n squared. Okay. Right, so what we need to do now is we actually go on and we continue by simplifying inside the square bracket now. We put the a's together and the jn's together. So it's 2a minus e to the minus a pi, square bracket, a, e to the jn pi plus e to the minus jn pi. And then we get plus jn, let's just explain what that a comes up. So that's a e to the jn pi, which is there, plus a e to the minus jn pi, which is there. So now I'm doing the same with the jn's here. E to the jn pi, that's the first one, and then it's minus e to the minus jn pi. Okay, so here we go. And then we divide by the same 2 pi a squared plus n squared. Okay. Now what we've got to remember here, e to the j theta, sorry, is cos theta plus j sine theta. E to the minus j theta, cos of minus theta, plus j sine of minus theta. Now cos theta is the same as cos of minus theta, and j sine minus theta is minus j sine theta. Okay, so we've got to highlight this one, and then this version of this is the best one for us to work with today. So look, here we've got e to the j, this is our theta n pi, plus e to the minus j theta. So it's that one plus that one with theta equals to n pi. So when we add these together, these bits cancel out. So we end up with 2 cos theta on the top for that bit. Let's catch up to where I am now, e to the minus a pi. So this bit here, this bit is actually 2 cos n pi, because theta is n pi. So this is 2a cos n pi. Okay. And then when we do e to the j theta minus e to the minus j theta here, so it's this one minus this one. So they cancel, and you end up with 2, because it's minus minus here. So it's 2j sine theta there. So it's plus jn times 2. Don't need to put that bracket in. Oops. Times 2, which I'll put at the front there. I'm taping. 5 minutes. 2 which I'll put in the front there, and it's 2jn times j sine n theta. We underline this. It's all divided by 2 pi a squared plus n squared. Okay. I'm going to need a new page now, unfortunately. So this is, right, let's simplify this line. 2a minus, now look, there's a 2 in each of these. 2 e to the minus a pi, and then that leaves cos n pi. And then, because we've taken the 2 outside the bracket, and we've got a j squared there with this 2 which has come outside the bracket, so it's going to be j squared is minus 1 minus n, I believe there, yep, minus n with the 2 outside the bracket, yep, sine n pi, and then all divided by 2 pi a squared plus n squared. Now what happens here, everything, see, we can divide these 2's, because that 2, there's a 2 with there, and that 2 multiplies all these, so that divides out there. Okay. Right, now the next thing to think about, right, cos of multiples of pi is either positive 1 or negative 1. And with this a, so that's either going to be plus or minus a. Because if you think about there's 0 pi, 1 pi, 2 pi, etc. So even pi's, this is the cos, the adjacent axis to the angle. So cos, and that's going to be 1 there, and that's going to be minus 1. That would be like 3 pi, 5 pi, etc. 4 pi. Evens that side, odd over there, multiples of pi. So that's going to change. Now sine of these, multiples of pi, that's always equals to 0. So I think we're getting close to finishing this now. So this is equals to we've got it as a minus e to the minus a pi times a cos n pi, all divided by pi a squared, about that, plus n squared. Okay. And I'll need to turn this over onto the next page, unfortunately. I'm going to factorise as well when I go into the next page. A outside the bracket, 1 minus, 1 minus e to the minus a pi cos n pi pi a squared plus n squared. Pi, this isn't equals a squared plus n squared, like so. Now, what we've got here is, cos of 1 pi is minus 1, cos of 2 pi is 1, cos of 3 pi is minus 1, cos of 4 pi is 1, etc. Odds are minus 1, evens are plus 1, multiples of pi that is. So the way that we can say this, cos of n pi, now it's powers of minus 1 to the n, I believe. Let's look at this, because then if n is 1, minus 1 to the 1 is 1, which is that one there. N is 2, here should be 1, 1 minus 1 squared is plus 1, so it works. So therefore it's going to work for the others. So this is going to be a 1 minus 1 to the n e to the minus a pi, all divided by pi a squared plus, do you know, I like that tool, but when it does that to me, a, which it does every time, it's me, I forget to put it back. Anyway, and I think we're actually there now. I don't think I can simplify this anymore. So what we can finally say, well, it splits it up. So that one has been used in there, that line there. So we need to look at the difference between n odd and n even. So the bits where the n comes in, well, n squared is n squared whether n is odd or even. So it's a over, I'm just got the way the answers are formed on the sheet to make this a bit easier. A over pi a squared plus n squared. So that means I've used that bit, I've taken that bit outside a bracket, so to speak. And then in here, so n odd minus 1 to the n is minus 1. Minus 1 to the n if n even is plus 1. So you separate them out into 1 minus 1 to the n is, so he's an even one first. So if n is even, minus 1 to the n is plus 1. So we're doing n even here. We'll do n even and then n odd. So this is 1 minus n even. So that's that bit there, that's plus 1, so it's minus plus 1, so it's minus 1 e to the minus a pi if n's even. And then the next one, if n is odd, it's minus 1 here. That is minus 1, so it's minus 1. So it's going to be 1 plus e to the minus a pi if n is odd. And that, folks, is my answer for this one. Now somebody's knocked on my door, so I need to see somebody. So I'm just going to go and find out what they wanted and upload this one. Okay, so that's question 4 done.